Okay guys, so let's create a program using this stop and this start, and we're going to do a 3-wire control, and we're going to have that controlling our system run. So let's go into our TIA portal. You've already followed the previous videos, and you have, let's just go back, you have, if you go to File and Drivers, you have a green light or a green check mark right here, meaning that you've connected up to your TIA portal, and now your Factor.io is talking to your PLC. Okay, we've already done on the previous video all our inputs and outputs, and if we take a look at our tags here, where are our tags here? We'll drop in all our tags, and all of those inputs and outputs, as seen on that previous video, are ready for us to use now. Excellent. Okay, so let's go over here. Let's go to main OB1. So we're looking at PLC1. We're opening up program blocks, and we're double left clicking on main OB1. That's our main organizational block. And we need to make use of these push buttons right here. So a stop push button. This stop push button is a normally closed. This start push button is a normally open. Okay, so if I go and hit play and hit view and dock all my tags, where is my stop push button? Okay, stop push button you can see is true at the moment here. If I press that button, okay, then it goes untrue. So that's a normally closed. When I press it, then the voltage is no longer going to the PLC. So I have voltage to the PLC, no voltage to the PLC. Okay, so in its rest state, there is 24 volts going to the PLC. If I look at my start push button, which is this guy right here, looks like there is 0 volts to the PLC. When I press that push button, you can see that that is now illuminated here. And that's demonstrating that there is 24 volts going to the PLC. So it is a normally open contact, and this guy is a normally closed contact. Okay, so let's go over here. Let's drop these guys in. We're going to grab our stop push button, and we want to make sure that the stop is still closed. As long as it is closed, then there's voltage going to the PLC. That means that it's still in its rest state. Okay, we've already done our tags here. So if I double click here and I start typing in stop, then there's my stop push button right here, being % input 0.1. So I'm going to click on this guy, hit enter, and everything should come in. Okay, so that's our stop push button. Next one is our start push button. So I'm going to drop in this instruction right here. This instruction is a normally open contact. I'm dropping that down here. Some people call this an XIC. I often call this an XIC. So we have 2 XICs in line here. So again, there is no hard and fast rule where a normally closed contact is an XIO and this guy is an XIC, or you can't just drop in normally closed and normally open. You have to think of the state in which it is and the state in which it will be energized. So this next guy is our start push button. So we're just simply typing in start, looking for start push button and hitting enter. And there's our next address there, % input 0.2. Okay, so both of these guys are examined if closed. I want to see that this is still closed, and I'm examining when this push button is going to be closed. So when I press that start push button, I want it to turn on. Okay, those guys are going to control a memory bit. So I'm going to click on my ladder rung here. I'm going to drop in an output. But this one isn't going to be a Q output. This is going to be % M0.0. So it's going to be a memory bit that corresponds to my system run. So I'm going to hit enter. All this is just a bit in the memory that goes from a 0 to a 1. It's a discrete output, but doesn't control anything outside of the PLC. It just controls other things and other rungs of my ladder program here. Okay. It doesn't have a name yet, so I'm going to right click on there. I'm going to rename that guy, and I'm going to call that guy System Run. So some people call that ready to run. I'll call it System Run. That's just saying that I have actually pressed that push button, being the start push button right here, and I have turned on that memory bit from a 0 to a 1. Okay, I need this to be maintained, so around this start push button, I'm now going to put a parallel rung here. Okay, so a parallel path for logic, not for current, but for logic. And I want to make sure that this guy is on. So the instruction that looks for something that's actually on is this one right here, the normally open contact, or what I've been calling an XIC, so examine if closed. So it's examine if closed, it's also examine if on. So I'm going to drop this down until I see green, put that in parallel, grab this with my left mouse button, bring it up until I see green, and let go of the mouse. And that provides me with that parallel path around this start push button. Okay, I'm going to label this guy the same as that output there. So it's not a true output, it's a memory output. If you're thinking about Allen Bradley, I believe this corresponds to like a B3 output, like a memory bit. Okay, so system run is right here. I'm going to click on this guy and ready to go. So I have my stop, my start. Those guys are turning on a memory bit. Once this turns on, I'm using an XIC, or what Siemens is calling a normally open contact, and I'm examining that this is on. Once it's on, it provides me another path to keep that output turning on. Okay, so let's compile that now. So we're coming up here to compile. So nice and simple to start off here, right? Like this is like, if you go back in the playlist, this is maybe the second or third video there where we did the 2-wire and then the 3-wire. But we're just building up. This whole rung here is going to change as we add in more and more instructions. Okay, so compiling is good, no errors, no warnings. Let's download this to the PLC. Okay, it looks good. Loading complete, error 0, warning 0. Let's just move this over. Let's drop this down. Let's put it into monitoring mode. And let me get the factory IO set up beside it. Okay, let's clear our dock tags here. Excellent. We're in the play mode here. If we go to File and Drivers, we'll just make sure that we're still talking to it. Good, we've got a green light here. So we have made use of the stop push button and the start push button. Those are the inputs that we've made use of so far. Going back to our animation here, we're hitting play. And now you can see that I have logic continuity through the stop push button. If I press that stop push button, then it will break logic continuity. You'll see that this is no longer green. Okay, let me just turn up the volume here. Okay, so when I hit that start push button, that will energize this system run bit right here. No lights will turn on because we don't have any %Q outputs that have actually been placed into our ladder here. So all we're doing is we're turning on an internal memory bit. That internal memory bit is going to go from a 0 to a 1. That will make this true and provide us with another path of logic when we let go of the start push button. Okay, so we're hitting the start push button right now. Okay, that turns on our system run, and there's that path of logic to keep it on there. Okay, so you can see that every time that I hit the start, then that push button on my program is changing state right here. Beautiful. When I hit the stop, it should stop. Beauty. Okay, so let's go offline. Okay, we want to bring in some indicator lights here. So integral to these switches are indicator lights for the stop and the start there. So if we're running, so we're going to put another rung here. So when we add a rung in here, we're going to do this. It always adds below that rung. And we're saying, all right, let's examine that system run is on. And if it's on, then let's turn on a light. Okay, so again, we're double left clicking here. We're typing in system run. Beautiful. That's good. And this guy right here, we're double left clicking here. And this one is going to be our start light. There we go. So we can see our start light is actually wired to %Q1.0. Beauty. So every time that this turns on, this will be true, and now we'll have a start light turn on. Okay. If that is not true and it's stopped, then we need another rung here. And we'll say, all right, if it's not on, so we'll use an XIO and examine if open or examine if off. We'll drop that guy in. And then from there, we'll turn on another output. That guy is going to be the stop light. And we're simply saying that if the system run is not running, so if it's a 0, so this looks for a 1, this looks for a 0 in the memory. And if that guy is a 0, then turn on the stop light. All right, beautiful. Okay, let's download this. You'll notice as I download now, it will actually compile it prior to downloading it. So there's our compilation there. We're going to overwrite their main OB1, yes. Okay, we'll drop this down, put it into monitoring mode again. Let's bring up our factory IO. And before this is coming in, a little bit of a lag here because I have both programs going on. Nice, we can see that we have logic continuity in that this is a 0 right now. So this is true. So that stop light is on right now. Okay, it will remain on when I press this push button, because pressing that push button has nothing to do with this guy right now. So right now it has no logic continuity to that M0.0. That M0.0 is off, so it's a 0. This is looking for a 0, so this is on right now. Sweet. So now when we hit this start push button, then this light should go off, and this light should turn on. Beautiful. So with just a momentary pushing of the start push button, that turns on our system run. We're maintaining that logic continuity, so even when I let go of that start push button, it's still on. And now we can see that because this is on, meaning that it's a 1, this is looking for a 1, and this is true. Beautiful. So now we got a green light that's on. Nice. So we've got a stop and a start there. It's a good start, guys. All we've done is just made use of a 3-wire control, right? So this is your standard 3-wire control, and now we have indicator lights indicating whether we're in the stop or the start mode. Beauty. All right, let's stop her there. In the next video, we're going to go and we're going to build on this. We're going to make use of the e-stop there, but we're going to make use of a flashing bit. So every time that we hit the e-stop, it's going to kick everything out. So nothing's going to work on the board here, and we're going to have this light flashing for the stop push button. All right, guys, thanks for your patience. We'll see you in the next video.